Today we will factor trinomials when the leading coefficient is not 1. Now the symbol that we normally deal with the number, the leading coefficient is A. The 1 for our exponent of 1 for the variable is B, and then our constant is C in this setup. What we'll be doing is factoring polynomials. Factoring polynomials is the opposite of multiplying binomials, and we will rewrite the trinomials as a set of factors. If you go back to our previous video where we were multiplying polynomials to one another, we had it set up to where there were 4 different terms that we were dealing with, and then we multiplied them together. We are going to be reversing that process today. A couple of the steps. The first thing you want to look at is if you can factor out a greatest common factor at the very beginning. It'll make sure that you're dealing with smaller numbers, which makes it more manageable. Outside of that, we can factor using the following AC method. AC is referring to our coefficients, our constants. The first step, we multiply AC and list out the factor pairs. And then we determine which factor pair add or subtract to give you a B value. We had a video earlier on that discussed that, kind of in the middle of our Unit 6. So if you want to go back to that to see exactly how everything works and the rules that go with it, I suggest watching that video. But then moving on, we will rewrite the trinomial with separated B value in the binomial AC method format. So we just use what we learned from that previous video of finding a product of a number that also has the factors add up to equal the sum. We'll factor the greatest common factors from each binomial, and then we will rewrite in a complete factored form. Now there are some ways to check in your calculator. You can set it to y equals, y1, y2 equals. For your AC portion, you also can plug that into the calculator. But for the handwritten way, we'll do this in example 1. Right now, my expression is 6x squared plus 19x plus 10. If I multiply my A and C, that is 6 times 10, I get the 60. Now I can set up all of my factor pairs that have a product of 60, being 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. Normally, the larger your number, your A times C, the more factor pairs you are more than likely going to have. So that's one reason why they say you would want to factor out your GCF at the beginning. Continuing on. The reason why we're doing this is because we want to break up our B coefficient. We want to change this 19 into something that can help us. And we do that by figuring out which one of these add up to equal 19. So the first one is 61. 2 and 30 is 32. 3 and 20 is 23. 4 and 15 is 19. So in this case, we found our number right here. We don't need to go much further. So we can use the 4 and the 15. So this part was in the separate video. Now I'm showing you why we learned that. We can rewrite our trinomial. We have 6x squared still. What we are going to change is our middle section. Instead of writing 19x, we're going to break it down into the 2 factors that we found, which is a positive 4 Now this is still in terms of x, and a positive 15. Still also in terms of x. And then we still have our last portion of the positive 10. So the ones that have been following along with my videos as well as in my class, this is the reverse process of the multiplying polynomials video. We normally started from this and then saw that we could combine like terms, and that's how we ended up getting 19x. We're doing the reverse. Now the next step, we want to separate these into two binomials. In fact, I'll use a different color to make it easier to follow along. Hopefully with the same size color. But we have this first portion, and we have this second portion. We want to get this closer to what we are dealing with at the beginning of our multiplying polynomials. Now if we look at each set of parentheses, we can factor out the GCF to simplify or set up simplifying our problem. If we look closely, both terms have an x involved, so we can factor out an x, as well as both numbers are divisible by 2. So they have a GCF of 2x, and if I factor this out, this leaves me a 3x, and a positive 2. 6x squared divided by 2x leaves 3x, and then 4x divided by 2x gives me the 2. We can do the same thing for our other parentheses. If we factor out a common factor, the greatest common factor, it's going to be a positive 5. So if I divide each term by 5, I'm left with 3x, and 10 divided by 5 is a positive 2. Now, one good sign that you are doing this correctly is you will have parentheses with the exact same expression or value on the inside. When this happens, you can actually divide both pieces by the parentheses. I can divide this section and my second section by the term, or the expression, 3x plus 2. Now when I do this, what I'm saying is I am factoring out 3x plus 2 from both terms. I call them terms because all this is being multiplied together. And what is left, same setup as before where I create the parentheses. If I divided this by 3x plus 2, I would be left with the 2x. And if I divide the second portion by 3x plus 2, I'd be left with the positive 5. Now that I've simplified this, or factored all the portions out, if you notice, our steps actually required us to factor twice. I have something that looks similar to my earlier videos where I was multiplying binomials. Binomial being our two terms, and each one of the parentheses.